Hi, dear student. Today we will going to discuss on the topic of deformation of solid. First, we introduce you about the deformation of solid. I tell you what is deformation, its introduction and complete detail. Now we going to our topic. See, initially the highlight point of the deformation of solid. What we find out in the deformation of solid: stress and strain. First, we will discuss on stress and strain in the deformation of solid, in which we read about understand that deformation is caused by compress tensile force or compress force. I will tell you about what is the meaning of tensile and what is the meaning of compression. Then we will discuss about understand and use the term load, extension, and compression and limit of proportionality. After that, we're going to the next point. What is the role of Hooke's law in this? Then our next point is recall and use the formula for the spring constant. After define the use of terms stress, strain, and Young modulus. After our next step, describe an experiment to determine the Young modulus of a metal in the form of a wire. All these things, tensile, compression, extension, Hooke's law, are obey on the one thing applied on a wire, and we will discuss all of these. After that, we will discuss on elastic and plastic behavior. In the compression or tension, what the behavior of elastic and what's the behavior of plastic? What will be the we will be the find out the difference between them. First point of the difference between elastic and plastic: understand and use the term elastic deformation and plastic deformation and elastic limit. Understand the area, the force extension graph represents the work done. We will discuss how much force applied and prepared a graph on the area which we applied the force. After, in the next step 3, determine the elastic potential energy of a material. In the elastic, what will be the what in which we study the elastic potential energy, which proportionality from the area under the force extension graph. After that, in point 4, recall and use elastic potential in force and its constant material for the material formed by within the its limit of proportionality. Now we are going to discuss all about these points in detail. The introduction of deformation of solid. In the deformation of solid, we see the definition of deformation. Deformation occurs when a force changes the shape or a length of a solid. It means that any body on which we applied a force, it changed its position. I create a diagram, you will understand. Suppose first this is our piece of rod. We are applying force in this direction. Then its shape will be changed after applying the force. Of a solid body. This is called the deformation. And next we will discuss about deformation types. There are two types of deformation, that is tensile and compression. The tension means we will study detail about what is tensile. The tensile means any object that we stretch, then its length is increased. Now, we similarly the piece of rod, we applying force on both sides or a single side, its length is increased from initial size. This is called tensile. A tensile means we applied a force on an object, its length is increased. Similarly, the meaning of compressive force or a compression, when we applied a force, the object's length or a size is decreased, is called the compression. Now we will discuss about basics. We know first step, the basic information, the basic terms of the deformation of solid. We applied a load. Load means force applied on an object. It may be tensile or compression. Second, extension. When applied a load, its compression, it decreases its length. When applied a extension, it increases the length of the body, and the compression, it decreases its length. Limit of proportionality, force directly proportional to extension. It means that proportionality means an object, suppose an iron, a plastic or elastic. If we take an iron, we need more force to increase its deformation. But when we take an elastic body, we need small force to deformation its shape. It means the body deformed from its original shape, then the value of energy from which its proportionality will be changed. It's called the limit of proportionality. For example, we take a box of solid body. We applied a force. It changed its shape just only in 5 Newton. Applied a force. It means that its limit proportionality is 5. Its K is the sign of proportionality is K, and its value is 5 Newton. Now next move, the next step, what is the behavior of Hooke's law? What is the meaning of the definition of Hooke's law? Hooke's law means extension is proportional to the force. The scientist Hooke's tell us about the body displacement, position, proportional, and force. The body change its shape according to applied force. Similarly, the simple example, when we applied uh, normal or small force, the body changes its shape very small. If we applied a large force, the body shape will be changed in large. So its formula is force directly proportional to x. Mean F is equal to x. It's mean when we applied a force is directly proportional to x, mean x is extension. How much we applied a force, that changes. Similarly, change in its shape. The K is spring constant. If we take a body spring, the spring K is depend upon proportionality is depend upon its body material strength. K mean material strength. If the spring is heavy or large, then its extension is more. Then we applied more force to change its shape. If the spring is small or its diameter is small also, then we need a very small force to change its length, mean it's change its extension. I hope you understand. If you want to ask something, then comment and tell me. I will answer you. Now we will move on the next step. Spring constant. I also already tell you spring constant means force applied on a body. How much we force applied on a body, it's similarly change its position or its size. If body is large, then the spring is stiff, mean heavy, loaded, then we need more force to change its shape. It's in Newton per meter. If the small, then soft spring, then we need small force and it's change its shape. F is equal to Ax. We find a force of the deformation of solid. When we find out proportionality of any body, then we rearrange its formula A and X divided by from F over X. I hope you understand. If you want to ask any question about this, then you comment me and I will ask you about this question. After we will discuss spring constant, we will move on stress. What's the meaning of stress? Stress means applied a force power on a body at a specific point of the body. It's called the stress. Suppose you take a body at that point, center of this body, you applied a force, and this area is all around is 1 meter. So stress is produced at that point, the shape will be changed like this. It's moved down. Similarly, stress is equal to force over area. How much we applied a force per area on the space. The formula is sigma is equal to force over area and the unit is Pascal, which shows that how much force acts on a material per unit area. Stress is, by the stress we understand how much force are applied on an object on per unit area. Suppose we applied 5 Newton force and it moved down, it means the stress is sigma is 5 Newton meters per square or 5 Newton per meter square. It means the area on the per meter square, the 5 Newton force is applied is called the stress. I hope you understand. If you want ask any question, comment me. I will ask you about this. Now, after the stress, we move on the topic of the strain. What is the meaning of strain? Strain means it is the ratio between when we applied a force on an object. You see that the simple body on which we applied a force, it changes its shape like this. It will be down. Suppose initially first is area is 2 meter. After applying force, its area will be become 1.8 meter square. Then we find out the strain mean after change the body. We applied this extension divided by original length. Mean extension After the extension, we applied a force, value will become 1.8 and original length is 2 meter. 2 meter, sorry, it's not area, it's a, we applied up on the length. We applied a force at a side, its length will be changed. I hope you understand the formula is x over L. X means extension and divided by its original length. It is the ratio of the similar point meter cancelled by meter. So it's become ratio. Strain is the similar object force and it gives the answer after changing its shape or size. So it's cancel the units and it's become change in its ratio. I hope you understand what is the meaning of strain. The change in its the body, shape or size we call strain. Our next step is in which we discuss about Young modulus. Young modulus, the scientist, what's the give idea about deformation? Young's tell that the ratio between stress over strain is called Young modulus. We applied formula stress over strain for the value of stress, force over area divided by length over, sorry, strain is x over L. When we will rearrange, it becomes F, L, L move up and A become denominator AX. This is the formula of Young modulus. Why we use Young modulus? Young modulus is the measurement of the stiffness of a material, how much the material is have power to not change its shape when we applied a force. When it changes its shape when we applied a force, its value is called the Young modulus. We understand this by Young modulus by an experiment. I hope you understand. If you want ask any question, then comment me. I will reply you. Or you want to learn, then contact me. I hope you understand. Now, experimentally understand what's the meaning of Young modulus. We need these apparatus: wire, weight, clamp stand, meter roll, or micrometer. Second, measure original length and extension. Calculate the stress and strain. Means stress divided by strain. Suppose practically take a stand, hang a wire. Simply you measure its length. After that, you grip, bind a load with them, this wire. You will notice that the length of the wire will increase due to the load. The change in its length of the wire is called Young modulus. The change when we change stress by strain, the ratio is called the Young modulus. I hope you understand. Now we move out on the next step. All the previous sides, we will discuss the deformation on the solid object. Now we are going on the discussion of elastic or a plastic deformation. Any soft material, when we apply a force, it changes its position or shape. If we take, we understand, if we take elastic material, what it will perform, and if we take a plastic material, what it will perform and show the result. We will also understand in which what is the difference between elastic and plastic material. First of all, we read and understand what is the meaning of elastic. See that elastic. Elastic means a body when we applied a force on an object. Suppose take a elastic. We applied a force. You also take elasticity. You also see elasticity means in a spring. You stretch, the size of the spring will increase. When we stretch the spring or any material, soft material, you stretch that its size is increased. Then after removal, the applied force, it's come back to its original position. Similarly, initially, when we are not applied the force, the spring on that position. When you apply it, they move on at that position. It means the change at this. These length create a change. And when we remove this force, the body move back to its similarly same position is called elastic material, or in same position with the same shape, original shape, is called elastic material or elastic deformation. So I hope you understand what's the meaning of elastic. Elastic means a body returned to original shape after the removal of force which we applied on it. But in plastic, When we applied a force on that object, it's permanently change its position, shape, or size. It's called plastic. Now next, I hope you understand. I take a body which made by a plastic material, a soft material. I stretch or compress its shape become like this. Applied a force on it. This is called, and when we remove the force, it's not come back to its original shape. We say that it is the when we say that it is the permanent deformation. And now we will discuss about the elastic limit. What is the meaning of we understand between this word limit? Limit means the last point of the change of the any object its property. When the an object pass out its limit, its property will also be changed. It's not come back to its original condition. This is called the limit. Similarly, elastic limit, when we stretch a elastic material or compress or stretch, we do that both things. Suppose I stretch enough, too much enough force that it not will be come back to its original position. After removing the force, it will not come back to its original position. It means its limits become, it change its limit, cross the limit, and cannot come back to its original shape. It means it become permanently deformed and permanently change its condition. It's called the elastic limit. Maximum stress before permanent change. In this definition, you understand. I hope you understand now. When we applied enough force, then maximum stress, after the maximum stress before permanent change, it create a permanent change on the body. Okay, now we move on the next. Now, when learn in the next page elastic potential energy. In the back, we learn about elastic. What's the meaning of elastic? A body, when we applied a force, it's come back to its original position. It's called the elastic. And the potential energy means the its maximum energy to it can means that to potential mean energy, enough energy to store the power in the in their system. Now we will see what is the meaning of elastic potential energy. Energy stored when a material is stretched. We see that in previous I tell you In previous, I told you that suppose take a spring. I stretch the spring enough force. All these force from which I stretch the material stored in which. Now its potential energy is increased. If when I remove force, it's automatically come back to their original position. Without applying any force, it go back to their position due to the potential energy which we provide to during the stretching. After removing the stretching, the spring come back to their original position by which energy that we provide by during the stretch. Elastic potential is equal to, you see that it changes its position, that is the x. It's change, it's cover a distance from there to there. This part, it's cover a distance, increase its distance length. Sorry, distance, I use word this. It's not a distance, it's a increase its length due to applied the force, which we show this length by x. After we know that formula of elastic potential is equal to, if we find out the elastic potential of any body, we take this formula, half elastic potential is equal to half force x, and we know that F is equal to 3 dot F is equal to kx. Put values, 1 over 2 become k x square. Area under a force extension graph is equal to work done. It means that the area create force extension, how much we applied the force, the those area will cover. See that we applied a force. If we applied more force, then more area it will be cover, and the length will also be increased. So it shows that area under force extension graph is equal to work done. How much we applied a force is equal to more than work done. During this lecture, if you any problem to understand any topic, any point, then you are discussed to me and write your question in comment. I will answer you in the comment back. In your I will answer and try to reply with full of confidence and with full of knowledge to you understand your question with the full of answer. Now we will see total summary of this topic of deformation of solid, in which what we read, what we understand, and the overall results. This, in which we first of all study about Hooke's law. We see that what scientist Hooke say about the Hooke's law. It says that any object, any solid object, we applied a force according to its property, it changes its length. If it is soft, then we applied less force. If it is hard, then we applied more force to change its length. It may be tensile or it may be stress or compress. In stress is equal to, what is the meaning of stress? We applied a force on per unit area. On an area, how much we force applied is called the stress, and the strain, when we applied a force on an object, the change its length. After the changing its change, we find out the ratio between its original and the after come to change its length. We find out the ratio after changing is called the strain. Strain is equal to after the applied force divided by its original length is called the strain. And the next topic, Young modulus, in which we study about the ratio between stress and strain. Okay. We will discuss in the Young modulus, we find out the ratio stress and strain. And final and last topic, we will discuss in the deformation of solid of elastic energy, what is the elastic potential energy, and what is obey and what is used for. In the elastic potential energy stored in an object are applied for change its shape, we need that is equal to 1 over 2 multiplied by kx square. K mean proportional of the material according to material value. What material we use? It may be soft spring, hard spring, it may be plastic, it may be elastic material like cloth, etc. Or X mean it's a change in its length. It's called the elastic energy, that elastic potential energy stored in an material when we applied the force. I hope you understand. If you want to learn, you can contact me. I will, if you want to learn, I will contact you and I will help so much. I will try my best. Thank you.